Okay, so what are the networking devices? There are so many networking devices are there. So for example, hub switches, routers, repeaters, modems, firewalls, checkpoints, VPNs. Okay, different devices are there. For us, it is important is hubs, repeater, switch, router, and modem. Even bridge is not much a device it is now. Here it is important one is I highlighted. I will give you a small overview here. Okay, then one by one we are going to learn. Yes, hub is a device we use for LAN communication and a small networks purpose only. Switch is also a same use LAN communication only, but we can use it for a small as well as a large networks also. Switch has a MAC learning properties there, but in a hub we don't understand what is MAC address or IP address. The router is used in a both LAN communication and WAN communication. It is a inter-networking device. It make a communication between different networks. So router is a best path to reach the destination. So router is shows best path to reach the destination. Modem is used to connect internet via ISP. So you want to connect ISP. Why? So to get an internet connection, right? So why how to connect? So using modem, we are getting connected through these telephone cables or a fiber optical cables. We are getting connected. Okay. So one by one device, we are going to see how it is works. Okay, guys, this is hub, how it is look like. You can type it is networking hub. Okay, hub means maybe it will show us in Google Images, so many things. So this is how hub is look like. Okay, so it's a simple device which is having a RJ45 connectors. So these are the ports which we can connect able to connect a devices to it. Okay. So a limited number of ports are there because of it is we are using for a small connection. And of course, what we are using here it is star topology. Okay, it is for a star topology. And see, this is how it is hub works kind of stuff. Okay, so it is not a intelligent device. It meaning is it does not understand any MAC address or IP address. It does not know what is a packet means. Okay, it is used for LAN communication suitable for small networks. It is a layer one device as per OSA layer. OSA having a 7 layers. The layer one is a physical layer. So example for a physical layer is a hub in a device wise. Guys, here it is hub function like this. You take a hub and connect your devices like this. I take a small hub, big devices. I have a devices connecting to this hub. Okay. For example, this is A, B, C, D, E, F. A send a packet to B. For example, A want to send a ping request to B. So what happened? It go to the hub. Hub will don't know where is B because it don't know any of a destination. It don't know what is the packet. Packet contains the source and destination address. It does not know what it will do. It broadcasts the packets to everyone. It does not understand what is their destination device, source device, or anything. What it will do, it is just a hardwire kind of stuff, no processing inside. So it will take a packet, forward the packet. It will send packet to everyone. So F received a packet, what it will do? It will drop the packet. E drop the packet. D drop the packet. B accept the packet. C drop the packet. How it will drop the packet, guys? You send A to P and same packet sent to others. C, D, E. Guys, every packet has a source address. Okay. Every packet has a source address and destination address. Look like this one. Source IP address, destination IP address, source MAC address, and destination MAC address. What is source IP address? APC IP address. Destination BPC IP address. Source MAC address, APC's MAC address. BPC's MAC address is a destination MAC address. So B received a packet and check it. It's a B's IP address. Yes, it's mine. C received a packet. This is BPC IP address. It's not mine. It will drop the packet. Okay. So source IP, destination IP address. Okay. So hub keep doing this broadcasting. Not only one time, guys, it is always. For example, you are sending a packet from C to A. C send a packet to hub. Hub will broadcast to everyone. It send packet to everyone, including A and other devices will get a packet. Those devices are connected to hub. Okay. Those devices will get a packet. Everybody drop the packet except A. So A accept the packet, remaining drop the packet. If someone is trying to tell something, tell me, no problem. Same thing I've written, guys. A send a packet to B. A send packet to A to hub, hub to all other devices. B accept the packet, remaining devices drop the packet. Not only one time, every time. So hub broadcasts the packets to every device in the network. Every device in the network. Because of this, guys, number of collisions will occur. Okay, because of collisions, it's a packet data loss. That's why hub we call it as a single broadcast domain and single collision domain means all collisions will occur at a hub level only. Hub level only. What is a collision? Packet is traveling like this and also like this, like this, like this. So too much in a one single line, multiple packets and unnecessary packets. If I connected here six. If I connected 60 devices, what happens? So many packets is keep occupying. Okay. Simply think, yeah, you want to send a letter to one friend, so and same letter is going to everyone. Unnecessary data leakage, right? There's so many problems in it. Guys, understand what is hub? This point mainly. Yeah, okay. Guys, so let's keep a class 1 second aside. Please try to understand few things. One is we don't know network connection, network connectivity. My compulsory respond. Second, you understand, you tell I understand, sir. If you don't get it, ask me again, I will explain it. Okay. If you got confused because of my speed or anything, I will slow down. Okay. Don't feel shy, guys. You are the person who is going to learn. You have to learn. Okay. Not me. I already learned. I learned I went to classes. I learned already 10 years back, 20 years back. Not 20 years back, at least more than 10 years back, 15 years back. I learned all these things. Okay. In my engineering final year itself, I learned all these things. At least in engineering also, I learned few things. Okay. So you have to learn. So you have to understand your interview questions. It is. That's the point I'm asking. You understand? Tell me understand. You don't understand. I will repeat it for you. No problem. Got it, guys?
Yes, sir.
Okay. Finally. Guys, next one is repeater. We can use hub as a repeater, but the meaning of repeater is so our this is a wire. Okay, our network we are using are UTP STP cables, right? And these wires support only up to 100 meters. At almost all 80 meters, your signal is start getting weak. But I have to send a message like I have a exit device is there. Some other device is far from here. Okay, maybe the signal is become weak at certain point, right? What I will use, I use a repeater, so then signal will be repeat. So I can able to send a signal for little longer than our limited range, little longer. Not like I will keep put a repeaters for a 1, 2, 3 kilometers kind of stuff. It won't work like that. Of course, you may give a one example. Olden days, we have a cable TV, means there is a cable TV guy having that dish antenna and all. From there, he ran a cable to house to house. After certain distance, the cable signal become weaker. What he will do, he will put a one signal booster or a signal repeater kind of stuff. Okay, so that's a point of repeater. So this is a repeater device, how it is look like. So one side we are connecting from one connectivity, another side signal. It does not boost the signal, guys. It is again regenerate as a normal signal. So your weak signal become normal signal now. Sometimes you can use a hub as a repeater, or we can use a specific repeater devices also. So this is actually it should be here. That is good. Guys, currently we can say a repeater means one example is Wi-Fi extender or Wi-Fi extender. Okay, what is this Wi-Fi extender? You have a internet connectivity in your home or office. In one place, internet connection is there. It is connected to your Wi-Fi router. From Wi-Fi router, we are getting to our mobile phone, laptops. We are getting signal from Wi-Fi router. If you are signal. If you are far, you are getting small signals, means weak signals we are getting or no signal at all. But we are in the same geographical space only. So see, in this room, this laptop is getting direct signal, good signal it is. In this room, we cannot able to catch up the signal. So this Wi-Fi extender, what it will do, it receive a signal. It should be in the both the ranges, both your Wi-Fi router and as well as your laptop or a desktop range. Okay, so it should be in a both range, means it would be middle. So it will take a signal and repeat the signal. So then your laptop or desktop in the another room will get a proper signal. So this is the Wi-Fi extender. So take it and give it time. So this is in this area. Guys, okay. So what is a repeater and a hub? Next device is switch. Hub and switches both we are using for a LAN communication. Guys, not only this, what is this, what is this, also differences also important. Both are used for a LAN communication only. Switch is layer 2 device, whereas hub is a layer 1 device. Okay, layer 2 device means it's a data link layer. Switch is used for both small and large networks. Hub is used in a only small kind of networks. Why? Because of that broadcasting property. Okay, because it's a more number of collisions. Number of devices are high means more number of collisions, more packet data loss in it. Switch is an intelligent device which can understand MAC address. It learn the MAC addresses of connected devices. Okay, it learn the MAC addresses of connected devices. Here we have a switch. Okay, every switch or every hub has a port. Every port has a port number. Port number one, port number two. Okay, okay. Every switch have a port. Some are having a 16 port, some are having a 24 port, some are having a 48 port. Okay, depends upon the switch. Yeah, that is enough. We have a devices which we are connecting to these ports. By connecting this PC to this port, port number one, maybe this is port number two, this is port number four, this is port number three, this is port number five, this is port number six. I'll put in numbers like port number one, two, this is three, this is four, five, six port number. A device, B, C, D, E, F. If you are connecting means there is a NIC, network interface card. It means it has a MAC address. Every device having an IP address, every Mac NIC having a MAC address. Hmm. Every device, every NIC has a MAC address, every device has a IP address. Okay, so switch learn the MAC addresses of a connected device. When these devices are communicating, the switch understand that the device's MAC address, this MAC address, which is connected to our device, will switch. Okay, so that story is there. I will tell the story. So we'll complete remaining things. Guys, again, intelligent device means it understand MAC address, learn the MAC address of connected devices. It maintain the MAC address table. That's we will going to explain now. Used for LAN communication, it is a layer 2 device and it is small and large networks. Large number of devices we can connect it because of it's by default switch having a multiple port numbers depends upon a switch. Some are 16, some are 24, some are having a 48 pin, some are having 72. And not only like that, guys, one switch to another switch, we can connect it. So like a extended start topology, we can connect a large number of devices. Switch initially broadcast sent to everyone like a hub. Okay, very good. Someone message. Okay. Switch broadcast a message to everyone like a hub, but initially only. Guys, again, every packet has a source IP address, destination IP address, source MAC address, and destination MAC address. Without addressing, we can't communicate. So when you are sending from A to B, again, A to B, packet is going from A to B connection. A send a packet to the port number one, first port number one. Then the packet goes to every device in the network. Why it is going to every device in the network? Every device in the network. Why it is going? Because of its MAC table. Because it's a MAC table. MAC address table or MAT, MAC address table. Okay. What is this MAC address table in a switch? Okay. Here it is like this. MAC address of a devices and switch port numbers. Every switch has a port number, right? Switch port number. First of all, when switch received a packet, it will try to locate where is B's MAC address. Where is the B's MAC address? So it is not mentioned here. So what it will do, it broadcasts to everyone. So C drop the packet, E brought the packet, everyone is drop the packet except B. B accept the packet. So in this time, what will happen? So what is the packet contains? Source IP, A IP address, destination IP, B IP address, source MAC address, and destination MAC address. Means that is a B's MAC address. A MAC address, port number one. What is that? Switch understand from the MAC address. It learn the MAC addresses of a devices. It understand A is belongs to port number because incoming side A packet go to switch to the port number one. Switch understand port number one is connected to this device which is having this MAC address. So it is form a network like this. Next, for example, another example I will tell. So try to understand second time at least. Yes, C send a packet to D. How C send a packet to this port number? It is 1, 2, 3, 4, 5 port number. It is port number 5. Okay, port number 5. Okay, because it's a while it is seeing source IP, destination IP, source MAC address, destination MAC address. What is source MAC address? C. Where packet went? Port number 5. 5. So what is my MAC address? What are the C's MAC address it is? And in this table, D's MAC address is not there. So what it will do? It broadcasts the packet to everyone in the network. D accept the packet, remaining drop the packet. Okay, guys. What is the use of this one? Now you can try like this. E want to send a packet to C, or you can take A. E want to send a packet to C, for example. E send a packet, it is connected to port number 4. Port number 4. So what is the addresses? Source IP, destination IP, source MAC address. Okay. Destination MAC address is this one. So what is source MAC address? E. Which port number? Fourth port number. E MAC address. What is destination MAC address, guys? C's MAC address. Is C MAC address in the list? C MAC address in the list? Yeah, Naresh. Nagesh. Not happen. Everybody is disconnected or what? On hold.
On hold, sir.
Okay, okay.
Unmute.
Tell me. Anybody? No problem. C is in C MAC address is in the list, right? Alright, guys. So it's on the screen. I pointed out this is a C MAC address. In the MAC address table, it is showing C MAC address.
Yes, sir.
And which port number it is connected?
Hi.
Very good. So I no need to send to everyone. So simply send to the 5 port. Simply send to the port number 5. Okay, simply send port number 5 and it will go to the CPC directly. Okay, so first time broadcast. Second time I done broadcast. But third time I didn't broadcast it. Directly I sent to the C. How it is possible? Because of MAC address table. And how this MAC address table is created? By learning of MAC addresses from the devices only while they are communicating each other. Okay. So like that, devices are communicating. So meanwhile, this switch will try to learn about devices MAC address, like a B's MAC address connected in a port number 3, D's MAC address connected in a port number 2. Okay, and F MAC address is connected into port number 6. 1, 2, 3, 4, 5, 6. Like this, it creates a MAC table. Using this MAC address table, it unicasts the packets. Okay. So switch initially broadcast means send a packet to everyone like a hub. Okay. But it verifies the MAC address table against the destination MAC address, which is mapped to port number. If it is finds packet sent to the that port means later unicast means initially it is broadcast, but once it is having the details in the MAC address table, so it will directly send to that destination. Otherwise, it broadcast. The packet sent to the switch does not know where is B. Switch broadcast packets to every device in the hub. Switch learn MAC address of A maps A's MAC address to switch port number 1. Okay. in the MAC address table. Like while devices communicating each other, switch learn the MAC address of the devices maps to their connected port number. Okay, so for example, E want to communicate it to C, and where is C? C is connected at 7. Packet sent directly to 7 port number only. So that is called a unicast. Switch is called as a single broadcast domain, but multi-collision domain. Why multi-collisions? Collisions occurs at port level only. The collisions will occur at port level. It means one single port. So multiple traffic entries are occurs. So the collisions will occur for that one only, not entire switch won't collides. Switch uses CSMA by CD, carrier sense, multiple access, collision detection. Normally our switches use CSMA by CD type. If in case you are using wireless access point, that is CA, collision avoidance kind of stuff. Number of collisions are less, so less packet data loss. Switch works with floating and unicasting. There is a different type of switches also there, like the method of switch functioning, like a cut through switches or forward switches also there. So these points. Okay, so guys, to one more point is we have to add, that is L3 switches. For example, you remember very well, that is switch is L2 device, and you said switch is L2 device. Maybe something in your organization, someone senior ask, do you know there is a L3 switches? Yes, there is a L3 switches. Okay, so layer 3 switches also there. It function as a switch as well as a router type. We use these switches for a inter VLAN routing and VTP type of configurations. Okay, so instead of using a router, we use L3 switches in the inter VLAN routing purpose. Even if you don't understand inter VLAN means, no problem. Again, guys, what is a hub? Hub is a not intelligent device. It does not understand MAC address or IP address. But switch is an intelligent device. There is a processor, circuit kind of stuff. It understand MAC address. It learn the MAC address of device connected devices. MAC address table is a MAC address table. It create a MAC address table and maintain the MAC address table. Switches and hubs both are used in LAN communication. Hub is layer 1 device, which is a layer 2 device. Hub used for small networks, but switch used in a small and large networks. Hub broadcasts the packets to every device in the network. Switches initially broadcast the packets to uh, every connected devices like a hub, but it learn the MAC address table. It use the MAC address table to check the destination MAC address. So if it is find it is mapped to any port number, so it will send a packet to that port only. That is like a unicast. So switch initially broadcast, later it is unicast, not like a hub. Hub is always broadcast. Okay. So that is about a hub and switches kind of stuff. Guys understand? Hub switches.
Yes, sir.
Router is also intelligent device. Router works with a logical addressing, means IP addressing. Not only IP addressing, different type of addressing protocols are there, but we are keep mind only it is a logical addressing. Currently, we are using all are using IP addresses on. Internetworking device. What is internetworking device? What is internetworking? communication between different networks. This is a different network, this is a different network. So we can make a communication between them with a router. So internetworking means it make a communication between different networks. We can connect to our more different networks using router. We use it both LAN communication and WAN communication. Router comes under layer 3 device network layer. Layer 3 device network layer. Okay. Next one. I said LAN and WAN connection. For example, this is a one geographical Hyderabad location, Pune location, New Jersey location, some other routers in between. These are all different location means different offices are connected to through WAN connectivity. And they're also connected to LAN connection. So for example, this office from this device, I want to communicate it to here. So from this LAN, I have to go through router to WAN, and I have to travel multiple routers. Finally, I reach here, then I will reach the destination. Okay. But how this device, from this device, how packet knows it has to reach, it knows it has to reach here, but it don't know the path, right? How to reach it. You have to go to railway station, but how you reach the railway station, do you know? We don't know, right? So that's like that one. Okay. Okay. So the router shows best path to reach the destination. Router or router. Actually, it is route. Route means path. Router shows best path to reach the destination. Router uses this routing. What is this routing table? The routing table in the router is telling that this particular network is located in this route, in this location. This particular network route. Like this, from here to here, here to here, here to here, how to go. Means in these routers having routing tables will tell you how to reach this particular destination. That too easy way. Means depends upon certain metrics. So which is the better path, the best path we can able to reach this. These routing tables can be configured or created manually. That is called static routing. And we can automatically create these routing tables by using certain routing protocols called dynamic routing. This for the dynamic routing, we are using dynamic routing protocols. IGP, EIGRP, RIP, YSPF are dynamic routing protocols. Again, guys, switches and hubs to the router. Switch and hub using a LAN communication. Hub is layer 1, switch is layer 2, router is layer 3 device. Hub don't understand IP address and MAC address. Switch understand MAC address, not IP address, but router understand IP address. Switch and hubs works in LAN communication, means only private network, only within the network only communication. But router make a communication between different networks, inter-networking device it is. Used for WAN communication purpose also. Switch tells to reach how to reach the destination um, part. Okay. Okay, we'll take it. Later we'll change it. Okay, next device, guys, modem. We discussed about a hub, of course, repeater, and we also discussed Wi-Fi extender for a repeater. switches, and then router. Now it is modem. Modem means modulator and demodulator. I have written here FM radio example. Guys, my voice signal is 20 to 20 kilohertz only. And my voice amplitude is also limited. But I have to send this signal for a very long distances. So I have to kept my signal into a carrier frequency so then I can send through it. So in our communication, so you are able to listen to my voice means I connected to a mic. The mic convert my voice into electrical signal, and my system convert my electrical signal into digital form of signals, and it is process that signals, cut it to the simple samples. Okay, then finally my system will send through our internet. So internet through you receive to your system, your application, and it is again convert back into the analog signal you are able to listen from your speakers. Okay, same for a FM radios. Someone is speaking, it is added to their high frequency signal, then it is distributed into the outside. Just for an example only, I'm giving modulator and demodulator, guys. Our LAN communication, LAN signal is a digital form of signal. We cannot pass these signals to long distance, means you have to send up to ISP, ISP to outside. So your signals cannot carry that much long distances. So we need a modem. Modem is convert your digital form into analog form. So using telephone cables or fiber optical cables, so we can send our signals, our data ISP. From ISP again, it will send to other routers kind of stuff. Okay. So nowadays we are using, already I told that one. Nowadays we are using our Wi-Fi routers. So our data is going to router to modem, which is built inside that one, and it is connecting to that cable, either telephone cable or fiber optical cable, or backside you some LAN wires we are using in a, some PPPoE type connection, point to point or Ethernet type of cables we are using. That's generally STP, UTP cables only in certain internet services. Okay. So any which ways it has to be sent up to ISP. Modem make you to connect it to ISP. Through ISP you are getting internet. So you want to get internet, you need a modem. Some Wi-Fi routers are having built-in modems inside. Okay, guys. So each device having its own purpose depends upon your requirements and depends upon your organization. You can use it. Got it, guys? Hub, switches, repeaters.
Sir.
Yeah.
Yes, sir.
Here, I want to tell about something which is like this. Um, Ping request. What is this ping? What is traceability? I have a device and I have a device. There is a connectivity. There are connected. There are having their IP addresses. Okay. It's a device PCA, PCB. Now I got a doubt. Can I able to communicate from A to B? So I want to test the communication between A to B. Okay. So what I have done at A, I go to the command prompt. I go to command prompt and I put a command called a ping command. So from A, so I am at A. So I have to give a ping, means I have to send a ping request to BPC, means B's IP address I given a ping command. So what happened? The request go to the BPC. like this. So this is called a echo request. In ping, we use echo request. Okay. So we receive the request, understand what you are sending. So it will reply to you like this. It will reply to you. So this is so when you are receiving a reply from BPC, when you receive a ping result as a reply from BPC IP address, means from A to B and B to A, communication is good. Communication is good. Okay. This ping communication, ping is a testing command, guys. It uses a protocol called ICMP protocol. Ping use ICMP protocol. The request what we are sending called a echo request, and we are getting a echo response from BPC. When you are getting reply from BPC outcome, then automatically we can understand communication from A to B, B to A is good. There is a connectivity. For example, APC IP address, BPC IP address. At APC, I'm giving this ping request. I'm getting reply from destination IP address, means communication is good. Ping uses ICMP protocol. Ping uses ICMP protocol. Okay. Ping uses ICMP protocol. For every communication, guys, there is an address and there is a protocol and there is a form of request. For example, HTTP protocol for requesting web pages. HTTP request, HTTP response. So destination device understand your request from your protocol only. Okay. So here I done a ping to google.com. So I went to the command prompt and I'm giving ping to www.google.com. I want to test, can I able to communicate with the google.com on that? So I'm getting reply from google.com IP address, means successful ping. So ping is a test, used to test connecting between devices. So tells your device is able to communicate with the destination. Okay. Next one is trace RT, guys. I will come back to the ping. Guys, understand how to use a ping?
Yes, sir.
Very good. So here can I reach google.com or not? I pinging to google.com means can I reach google.com? Yes. Because of these replies I can understand. But I got doubt how I reach google.com. Google.com is not in my office, right? It will be there in a somewhere in a some different location. So I use trace RT www.google.com. It will tell you how you reach the destination. So first of all, I reach my default gateway. I reach my default gateway. Then it is my ISP connectivity. It will take time sometimes. And as any delay in between, it will. We have to reach by 30 hops. Okay, hop means guys jumps. As I said earlier, so there is a different routers are there in the internet. So many routers are there. Why internet? Internet is connection of networks of network. Okay. So you see these many routers in network. but my PC is here. I'm going to my first router, my default gateway only. My home office router or a home router, first I have to reach. Whatever the destination you are going, first you have to reach here only. So because it's our default gateway. From here, your ISP, from your ISP to outside. What happened to this? Taking time. Okay, yeah. So in ISP only it is travel. So it is showing sometimes star. Star represents it taking more time than usual. That's why it is taking. Okay, how much time it is taking from jumping from one place to another place. All time delays it is showing. See, finally, I reach my destination. I started from my PC to my gateway, and gateway to some other routers, and finally reach the destination. Okay. So trace RT will tell you how you reach the destination, the path you reach the destination. So this is so who will tell which path you have to reach in between lot of routers? The routers will tell you how to reach the destination. Guys, understand ping and trace RT?
Yes, sir.
Correct. Ping. So here again I'm telling ping guys, ping. If you do ping to your some destination device, you are getting reply from destination IP address. I said it is good. But if in case you are getting destination host not reachable, you are getting reply from ping IP address and something you are getting means like this you are getting means it is good. So from my device to this particular device, communication is good. But you are getting destination host not reachable like this. It is reply from your own device. It is not from the destination. Can you see? It is not from the destination. It is from your own device IP address. And destination host not reachable. Meaning is either this device is not available or you are entered a wrong IP address. You're given a wrong IP address. A device is down or disconnected. Either device is not there, a device is down, or you given a wrong IP address. Sometimes you will get it, sometimes you will get a request timed out. Instead of destination not reachable like this, okay, it shows request timed out. What is meant by request timed out? Again, destination host not reachable or a request timed out having some common things is destination device may be down, IP address wrong, maybe destination is disconnected. But if you are getting request timed out, not only these three possibilities, other possibilities are there. Maybe at a destination, the firewall is blocking your request. What is the use of firewall? So where it is? This firewall blocking your request means you're sending a packet to me. My firewall is not allowing you to accept the packet. I block the firewall. Using a firewall, I block it. Okay. So anyone is trying to ping me, block it. This ICMP protocol, any echo requests are coming, block it. Don't give it to me. That is a firewall duty. So anything anonymously is coming to at your PC, the firewall will block it. So like that, you send a request to the BPC. You're trying to ping from A to B. B's firewall may block your request. Then also your system is waited a long time for a reply. Your system is waiting for a certain time to get a reply from destination. It is not received, then it will tell request timed out. You send a request, but you are not receiving a reply from the destination. Means their firewall is blocked. So not only these three possibilities, also check the destination firewall thing. Path not available means You want to reach the destination, that path is not clear. So wrong path direction, wrong IP address, wrong path, or a wrong network IP address it is. So actually I have to put a 192 here, or a 192 to 194. In between, okay. But it is different network now. So obviously request a timed out. Okay, guys. So three kind of outcomes plus one outcome is also there. So other one is like a generic error. The generic error usually your device is disconnected from the network. You are not connected to any network. Okay. So that is generic error. This is about your ping and trace RT, and based on the ping replies, what we can able to understand, so we can able to communicate or we are unable to communicate. Okay. Ho- How to troubleshoot? Check the physical connectivities, check the both side of IP addresses and their network IDs. So how to do it? Check physical connection for both sides, both source and destination, physical connectivity, and check IP address, check IP addresses, check IP addresses, their network ID. Okay, meaning is network ID must be same in same LAN network. You are communicating to a device in the same LAN network, network ID must be same. Okay, check firewall at destination device. Okay, firewall, built-in firewall is there, no? So usually the built-in firewall kind of stuff. Okay, guys understand difference between ping and all kind of stuff? Hmm? Compulsory each and every device, and ping command is also very important. Differences between the devices, each device, what it is, differences. So guys, take a break, come back in a 5:10. Okay.